let us go with one by one module. Again, to the GUI. So here, firstly, that system has many predefined things available. Okay, and on top of it, there is n number of customization that any user can opt for. Now, when it comes to the performance monitoring, okay, how devices can be discovered into the system. I mean, how the platform would identify that, okay, this is the network infra that we have to monitor. So for that, there are two major approach. One approach is we discover the devices by creating a discovery profile of those devices. Now, when we look down to any such platform, okay, how any platform is collecting data from end devices. What I mean to say is that let's say we have a Windows server. So on what basis Windows server is communicating with metadata? Okay, or on what basis, over what thing the Windows server is sending data to metadata. So we uses all the native protocols to do the same. So for Windows, we use PowerShell. For Linux, we use SSH. For network devices like switches, router, firewall, we use SNMP v1, v2c, v3. For databases, the system collects data over JDBC. For URL monitoring over HTTP, HTTPS. For cloud infra, it uses the protocol cloud. For other applications, it uses JMX, JMS, and everything. So over all the native protocol, system collects data, metadata platform collects data from the end devices. So firstly, we create the credential profile. Then, creating the credential profile, we have to go forward with discovery of those devices. Now, when we discover, what we can do is that during the discovery, we add the host, we add entire IP range of that. We add the CSV. We can also import it through CSVs. We can also do it through CIDR. So any of this range we can give for discovering these devices into the platform. Once discovered, they will be listed under the monitor section. Okay, wherein entire segregation is done. Like we can see servers and app, network, cloud, service check, virtualization, all the service level data, process level data, interface level data that the system captures. Okay, all this would be showcased on the monitor side of the platform. So this was one of the approach, that by creating the credentials by all the native protocols, system is collecting data from the different endpoints. So that is one of the part. And the other part that we have is the agent-based discovery. Yes. So as I had mentioned during the presentation that as a metadata, we have our own agent as well, which helps us collect data from end devices. Okay. So specifically for servers and applications, we have developed this agent. Now, using group policies, I mean, using GPO, we can deploy this agent to the endpoints, to servers, to applications. And this agent will collect all the data. That it will collect the data of metric, like, okay, what is the CPU utilization, what is device details of that specific server app, disk matrix, process matrix, Windows service matrix, anything. And the same agent will also help us collect the logs that specific device is generating. Any kind of log that the device is generating would be collected through the log part. Okay, so this single agent can be deployed on servers and applications for collecting the data. Okay, so these are the two major approach: the discovery option or the agent based option. Okay. Okay, so these are the two approach that how the devices can be added, because once the devices are added, then only we'll get the device details. So coming back to the monitor part, so here, as I mentioned, that system captures multiple types of details from the different devices. So when we look down to servers and applications, now, as I had mentioned, right, that system has many of the things inbuilt. So what when we mean that it has inbuilt is that there's all the details that currently we can see, like there is CPU usage, memory utilization, network packet details, response time details, the availability details, system disk utilization, how the page faults are, right? Entire analytics, load average over this specific server, okay? Swap memory details, plus different processes running on this specific server, interface wise, in traffic, in packets, out packets, and everything. So all these details that we can see over here is captured by the default template of the system. Many a times we have come across customers that other than this, they also want other details like power utilization, uh, and some and any other KPI that they might be looking at. Okay, then yes, those kind of KPIs also can be incorporated on the template level. So as soon as we rediscover device, we would be also I mean the system would also help us capture that specific KPI detail by incorporating different MIBs or OIDs into the system. Okay, so this is one of the example that this is how the templates would capture the details over each and every specific device. Now, when we say that system has the process running, so system will also capture the process related data, that okay, what type of process it is, on which server it is running. Currently, what is the process ID? What is the process status? Or whether that current process is running or not. It is an up status or down status, or how the availability of that process. And if at all any alerts have been configured at process level for that device, those alerts would also be showcased over here. So I mean system is so robust enough that as soon as we start monitoring any devices, it goes drill down to all the basic details of that specific device. Okay, and on top of it, like what we really meant is that when it comes to servers and application, we should be able to go up till the process level, right? Process and service level of any device. So that is what we have done, that servers and applications, we can drill down to that specific uh, process and service data as well. Okay, so now uh, again moving on to few more devices. So like when we say that on the DB side, so we can check the connections, we can check the threads, we can check the performance. Yes, so I was showcasing the MariaDB template, right? That what system captures on it level, plus any replication details, any active policies for that. Okay, those details would be captured on DB side as well. Okay, plus any other application that we look into. These are all the different type of devices that system currently carries. Okay, now this is one of the Oracle DB. So as I mentioned, on the documentation side, that Oracle DB, when we start monitoring Oracle DB databases, what details the system would capture? It captures the current active sessions, PGA details, cache memory detail, transactions, disk details, job, all the current jobs running, right? Query details, namespace details, table details, and everything. Okay. Now, coming back to the dashboard page. Now, as I had mentioned, that it's an universal platform, right? So, firstly, we have this performance summary dashboard, which is which gives us an aggregated performance summary view of different type of devices that we have discovered. Okay, let's say that we have a widget which says that system CPU percent by group. So firstly, the system has multiple groups available. Okay, like Windows servers, network devices. In that, it has a group of switch, it has a group of router, it has a group of firewall, it has the Active Directory group, user group, right? So overall, it is giving, this widget is specifically giving us a data on how the data is being consumed by each group, or we can say the CPU consumption by each group. So we can see that, okay, Active Directory is consuming this much of data, network switch is consuming this much of CPU, right? Or routers or any Linux servers, right? Anything. So it gives us an entire aggregated utilization from each group of devices. Same way, we can also refer to this specific widget, which is majorly on the memory usage side. Okay, that how the memory is being utilized by different groups. So we say that, okay, there is an Active Directory group, Microsoft TIAS group, Linux server group, how much memory each group is consuming. So that widget gives us an entire highlight of that. Same way, these are all the standard defined filters, like top 10 monitors which utilizes the highest CPU. Those can be servers, network devices, virtualization, cloud, anything. But they are the top 10 utilizers. Same way, top 10 monitors by their memory usage or memory percent. Then top 10 monitors by their latencies. Top 10 monitors by their packet drops. Top monitors by their disk used percent. Now, monitor wise, each monitor is consuming how much of traffic, right? So what is the in traffic, out traffic, right? Interface wise, if we want to check, then that can also be captured on the performance summary dashboard side. System carries highly intuitive dashboards. We can have any custom dashboards created from here. Any custom widgets can be added, and on top of it we can have any such dashboards available. Okay, and the best part is when it comes to any customers, CIO and CTOs, okay, the system gives you a specific specific such dashboards as well, which are only for those users, where when CIO comes to this specific we can say dashboard, they'll get only the highlights of the platform. Same way, the CXOs, they'll only receive the highlights, like, okay, this is how the infra is performing, whether and when to work on which area specifically, whether we need to work on the network area because the network is utilizing highest of utilizations as per this widgets, right? So specifically for those customers, any customers, we can have such dashboards created which are specifically for the CXOs and CIOs. Okay, again, going back to the monitor part, so we currently look down to the servers part. Same way we look into the network side as well. Okay, wherein on the network side, again, any type of network devices can be added. Let's say, for example, we go for this specific firewall. So what firewall will give us? Firewall, firstly, just a moment. Yes. So over the firewall, what data the system is capturing? So system captures the details, like, because with the firewalls or with any network devices, we also give the interface monitoring part. Okay. By default, the system is monitoring all the interfaces that have been configured on any switch, on any router, or any firewall. Again, this is one of a, we would say, added advantage with the platform, because there are many platforms out there in market which charge, their licensing would charge based on number of ports or based on number of nodes or based on number of interfaces as well. But with this platform, we have a very straightforward licensing policy, that if there is, we want to monitor one firewall, and with that we also want all the interfaces to be monitored, the system would only require one license of firewall. That's it. There is no need that we buy a separate license for port monitoring or interface monitoring. Within that firewall, n number of interfaces are connected, there, then all the interface details would be captured by the system. There is no extra additional licensing or charge for that. It is what the default thing with the system. So when again, coming back to firewall, so here we can see that, okay, currently how many interfaces have been configured on this firewall, how many active sessions are there, the disk utilization, CPU utilization, the actual availability of the firewall, okay? Plus interface wise, we can check the details that how the interfaces have been configured. How many of them are in up status, how many of them are in down status. We can see the entire details of that interface, the traffic utilization, which specific interface it is, okay, in traffic, out traffic, what is the data in we can say mbps or gbps or kbps, how the data is flowing. So entire graph system showcases, okay, availability of that specific interface. And yes, again, as I mentioned that once the interfaces are discovered, system has many policies, default policies available, and on top of it we can have any active policies created at interface level as well. Okay, this majorly showcases how much is the in traffic and how much is the out traffic of that specific interface. Okay. Now, again, coming back to site VPN details. So now, if at all we have a core firewall, right? And from that core firewall, we have configured the VPN. Okay. So with that as well, okay, the system will capture the site to site VPN details, that okay, how the VPN has been configured. Moreover, it also captures the remote VPN users, that how the remote VPN, how different clients have been connected through that VPN, okay, through that firewall. So this again is captured by the default template of the system. And for this as well, it gives you the duration, that since how long the client has been connected. Other than that, on the matrix side, matrix explorer side, you can have the entire visualization for any KPI. All these are the standard KPI that system is collecting. Let's say, for example, we want to see that, okay, currently how many active sessions are there for this Fortinet firewall. We can see this many is the minimum range, this is the maximum range, and this is the average connections that comes to when active connections, active sessions connected through this firewall. Okay, we can drag and drop any such device. Let's say we want to see that how much system disk use bytes are. Then again, here it will give us that okay, this is the average utilization for that. Same way, like we want to check the active remote VPN sessions, then it will give us an average that okay, on the remote VPN side, this many are the average connections that have been identified. Okay, any drag and drop we can perform, and it gives us all the average utilizations for that specific KPI. Okay. And lastly, the active policies. So on the firewall level, if at all these policies have been configured, okay, and for each policy we can check that what is the value of that policy, and how that specific policy has been breached. We can also refer to this is an availability alert that is being triggered, right? So since how long that alert has been triggered, or because of which policy that alert has been triggered, all the details can be captured on the policy level of the devices. Okay, this we call it as the SNMP device catalogs, okay, wherein we would have all the catalogs present. Now, moving on to the network side. So as we look down to the firewall, right? Same way we can look down to the wireless devices as well. Which on the wireless side, what as a default device captures, it captures that how many current access points have been configured, how many APs are there, client details, response time, packet loss, availability, each client wise, how much is the packets, right? Total packets, those details can be captured, plus system. Here we can see that over which access point it is working, whether the access point is in up status or down status, the IP of that, clients connected to that specific access point, MAC address details, uptime details, and everything. VLAN summary details and all this would be captured as a standard on the access point side. Plus, if at all we have the ROG device details, those ROG device details would also be captured. Okay. Same way here as well, we have all the KPIs. We can drag and drop, and we can have the analytics for that KPI right from here. Now, let's say, for example, let's say Ruckus active VLANs, right? So it gives us the data in last 6 hours. There is no as such data. But if we go for last minute, it can have. So any KPI can be drag and dropped, and over that we can have the device details. Okay. Lastly, the active policies. Active policies specifically configured for the Ruckus wireless. So we can check all the policies, okay, and accordingly we can see that whether any of the policies have been breached or not. So yes, I was showcasing this firewall topology. So what happens is that as soon as the firewall has been provisioned, right, it will showcase you all the switches or routers, access points connected to that firewall. Okay. Now, is here you can see there is a Linux app, right? With that, there is Nginx, there is Apache Tomcat application running, WinFly running, Apache HTTP running, right? So on the topology side, all these things would be mapped. And yes, all the L2, L3 devices can be mapped on the topology. System supports both the ways. There is automatic topology creation and there is a manual creation as well. Now, while you discover any device, okay, what system is doing is system is giving you one option. Let's say I have created it through the firewall. So when you discover the firewall, right? Just a moment. Yeah. When you discover the firewall, okay. In the firewall discovery only, we are giving the option. Sorry, not just on the firewall discovery side, but on the network virtualization and on the cloud side, during the discovery only, we are giving this option that this is the entry point of the topology. That's it. As soon as the system gets to know that, okay, this is the entry point, it will start mapping all the devices which are already provisioned as a top on the visualization side in the topology part. Okay. And yes, one more thing, that this topologies to be created, right, at device level, we have to we need to have few of the protocols enabled, right? So like there are protocols like CDP, LLDP, ISIS, which needs to be enabled on the device level so that those devices can be mapped on the topology. Okay, so I guess we have covered the matrix part. Most of the device templates have been covered. Just few more things on process and service data, right? So we can check that these are all the processes running on the Windows devices. These are all the processes running on different devices, right? We can also uh, see each of the process as well. We can see the availability of the process. We can see the memory utilization, process threads, and everything. And if at all at process level we have configured any active alerts, those alerts can also be showcased on the on the monitor section itself. Okay. Lastly, the device interface side. So as we mentioned that we are also supporting the interface monitoring. So all the interfaces that we have discovered would be showcased on the interface side of the system. Each interface wise, we can see the availability, traffic utilization, up status, down status. Okay. Yeah. Any other details or any policies that have been configured at the interface level. Okay. And lastly, on the other side, so on the other side, any IP phones, IP cameras, URL monitoring, any other device monitoring that system might have, okay, that would be showcased on the other device part. First, we have the mail server settings. We can set up the mail right over here for the outgoing emails. Okay, that entire setup can be done over here. Now, when it comes to SMS, we just have to define the SMS gateway URL, and we have to test it with the the main SMS provider, the gateway basically, and it will start sending you all the emails regarding, because there are many default emails available. Okay, for all the actions, for all the alerts basically. Now, when we come to integration, so we have already integrated the service ops. So wherever you want to integrate such things, we would be looking down to the server URL, from where it would be communicating the client ID, password, secret key, and everything. Plus, there are a few of the prerequisites, okay, that needs to be there. So that we will get from the doc side itself, that few things we need to take care from any other third party that we are integrating. Okay, so it's just all these details would be required when we integrate any specific platform. Now when it comes to majorly your as your questions were, so we have the policy settings available, which is for metric, log, flow, trap, everything. So when you go for metric policies, there are many standard policies available. On top of it, we can have any custom policy created. Now, any device, if it's going down, if its availability is breached of, or its log have been hampered, right? Or we are getting too much of error logs from a specific device. So in that, we can set the entire alert message over here with subject line description. We can set that we want to notify to which team, send an email notification, send them or update them through the SMS part. Okay. And then comes the actions, wherein any actions that, as I mentioned, that okay, this is a service ops ticket. So whenever
Mm-hmm.
if there is a CPU breach, okay, if
Mm-hmm.
system CPU is reaching up 98%, then we want an alert, we want an SMS alert, email alert, and also we want to raise a ticket on service ops. So we just have to select those actions over here. And all these actions, again, all these actions that system might be performing is through the run books. Okay, so we have run books available with the system. Run books are specifically all the actions that we want to perform. There are many run books available. On top of it, you can have any custom run book created. These are majorly the proactive actions that we say. Okay, and this is one of a very big highlight of this platform, because we developed this run book. I mean, entirely it's on whatever custom thing we want to do on the endpoints. Let's say we want to create one service, I mean a run book specifically for the Linux devices, or let's say for the SNMP. So we add the OIDs of that specific device. We select that device, or we can also select a group of device, right? So let's say I'm just selecting from network device, I'm selecting the Cisco system router group. Okay. And for specifically for this device group, I'm writing a script which can be in Go and Python. And using that script, I can take any automatic actions over the routers, specifically the Cisco routers, which have been discovered into the metadata. Okay. So any such custom actions, customer, they can define it over here, and automatically they would be triggered whenever the policies are breached. Okay, now let's say we have multiple customs written. Let's say this is one of the run book which says that it kills the Linux process. Okay, it is for all the monitors, it is not specifically for any monitor. Okay, this is the entire script that has been written which kills the Linux processes. Okay, over that Linux devices, that custom uh, code we have written over here according to which it's done. So I hope now you get it, that how the actions would be, how the notifications would be, and how the integration would be.